All right, Mr. Murray. Your question to me has always been, what is a Newton? So in order to find out a Newton, we need to find the equations and the physics behind what goes into that. So first thing we're going to have to look at is the force equation, because a Newton is equivalent to force output. So what's the force equation?
Mass. Force equals mass times acceleration.
Force equals mass times acceleration. Great. All right. So once we break this equation down, you're going to have newtons is equal to kilograms, because that's our measurement of mass, and meters a second squared.
Okay.
And that is a unit of acceleration, which is derived from meters, which is the unit of measurement. The first second is going to give us our velocity component, and that would just be the speed of an object. And our second is going to give us its acceleration.
Okay.
I'm just going to abbreviate it as
Wow,
accel.
I love that.
Great. So, how does this relate to anything we do? What is a Newton? How can we determine that? So, if we're going to set 1 Newton equal to 1, and we're going to try to solve for kilograms, we know that on Earth, that our gravitational pull pulls us down at how much?
9.8 meters per second squared.
9.8 meters a second squared. And across this, I'm going to show you the actual variables dropping out. So kg m over s squared is equal to kg times meter second squared. So that's what we did here. This is the formula in terms of just the variables. This is in terms of real world solving. So we're trying to solve for kg in both equations. So in order to get this to come over here, we're going to have to divide 1 by 9.8. And that's going to give us our kilogram variable.
Okay.
Looking over here, you're going to have kilogram over meters a second squared over meters a second, because we just took the acceleration component right here and dropped it down here, is equal to kilograms. So we're just dividing both sides by the meters a second squared. And that's going to cross it out like that, leaving kilograms over here and kilograms over here, so we're all good there. And this is going to give us about 0.1019-ish is equal to a kilogram. So that means that if you were to have a 0.1019 pound, or not pound, kilogram object and drop it, that would equal to 1 Newton of force.
The minute it was dropped.
The minute it was dropped.
When it started accelerating toward the ground.
Yes.
Got it. So Newton is a measurement of mass times acceleration.
Newton is a measurement of mass times acceleration.
Cool.
So theoretically, you can do that with anything, such as throwing a ball and all that other stuff. But we're going to use that in terms of finding if somebody can flex their elbow, for example, in a bicep curl.